Okay, let's see. Let's make sure that this is working. Okay, this looks like it should be good. Well, this is the last video prior to our count assessment that I will be doing. And well, this is kind of good, kind of bad, right? Hope that you are studying. If not, then that's kind of bad. But if you are studying, it's good. Hope everybody does well. But I'm gonna go ahead and do these problems. I'm about 32-ish minutes until y'all start showing up to first period. So let's see what I can do. Okay. In this triangle, we have to classify EFG by its side lengths. Okay, side lengths, there's only three kinds of triangles. There's scalene, isosceles, and equilateral. So D should have automatically been eliminated. And so remember the properties of scalene, isosceles, and equilateral. Scalene has no congruent sides, isosceles will have two congruent sides, and equilateral will have all congruent sides. Okay, so let's go ahead and try this out. Something that I think is going to be a little bit easier for us to kind of manage with this kind of problem, instead of having to find distances all the time, I want you to take this approach. I want you to make a right triangle with this side length. Here we get a value of 3, here we get a value of 5. You do the same thing on the other side. You get a value of 3 and a value of 5. Well, if I have 3 squared plus 5 squared equals c squared, and 3 squared plus 5 squared equals c squared, then these c squareds are going to equal each other. Okay? And so because these side lengths equal to each other, and I know one of them is supposed to be gf squared equals fe squared, and I simplify the square roots out, or the squares out, the square root, I get that gf and fe must be congruent. So I know at the very least I have two congruent sides. But then whenever I do it this way, I get 2 and 8. Well, 2 squared is 8 squared. More likely than not, it's not equal to the same c squared. So C has to be our correct answer here. Just a little bit of a shortcut, a little bit of a like, easier way to do this problem. Next one, which of these statements is true for any value k? Well, remember k is the scale factor. Okay, so definitely have to remember that. So we want this to be any value, not one specific value, any value. Okay, so if we look at f, where it says 2ab equals ad, that's essentially saying we're taking our k times the new equals, or sorry, not times the new, times the old, and putting it equal to the new. Okay, because we're doing ABC dilation into ADE. Okay, so that's essentially what we're doing here. And 2 is a specific value of k. That one can't be correct. Okay. G, AD, and DE are perpendicular. Well, first off, we can't even confirm that this is perpendicular anyway. So that should kind of answer your question anyway. But humor us for a little bit, right? If we were to have a triangle that's very obviously not perpendicular, like this one, and we were to say that, oh, well, if this was the triangle, does that mean that these two angles right here are right angles? Again, it's just not enough. There's not enough information to tell from this. So G is just not correct. AC and CE are equal to each other. That's possible, yes. Possible, but that's a very specific value. In this case, we would need a K value of 2 for this to work. And J is going to be the correct answer here. Okay. Because we always know that these two are supposed to be parallel to each other. Unit 3, find EDG, which is this angle. Well, luckily we know so much information about transversals and parallel lines, we can say that these two are going to be congruent because they're alternate exterior. Well, if alternate exterior angles exist between those two angles, that means that they're congruent, which means that EDG is 2x plus 5. And if we are on a straight line of FG, that means that angle FDE and EDG are going to be supplementary, so we add them together. X plus 2, 5 equals 2x plus 5. Oh, not equals, sorry. Plus, and they both equal into 180 degrees. So combine like terms, subtract 30, 3x equals 50, divide by 3, x equals 50. Careful though, that's not what I want. I want EDG. I'm gonna plug it right back into EDG. 2 is 50, it's 5, 100, it's 5, 105. So H is gonna be the answer. Nice. Which of the following represents the coordinates of point A after the following transformations? And this is one I think a lot of us kind of tripped up on, because we can see this y equals 1 line, and y equals 1 is a horizontal line. It is this line right here. Okay, y equals 1. And this is actually not as hard as we may think. Okay, and so we want to first off find what point A is. So we're only going to really transform A. Okay, we're not going to worry about B all that much. But if we're reflecting over any line, we're going to take the distance from the point that we want to reflect and the distance from that point to the line that we want to reflect over. And so if we see here that this right here, that is 1 unit. That means I'm going to reflect over 1 unit. So 1 unit down. That's my new A, at least for transformation 1. And then transformation 2 says let's translate down 3 units. So 1, 2, 3. That's my A. And I get -3, -3 as my answer choice, which means all these are incorrect except for F. Okay. In the diagram, QS and PR bisect each other, not just one, they bisect each other at point T. Okay. And so this is the point T that they intersect at. We know that Q, T, and TS are going to be congruent. And we know that PT and TR are going to be congruent. Okay. Because they bisect each other. But then we also know that these have vertical angles. Okay. So if these have vertical angles, we have two side lengths on the outside of those vertical angles. I have SAS. And because I have a SAS, I know for sure that all corresponding parts of congruent triangles are congruent, CPCTC. Okay. And so what CPCTC tells us is that angle P is going to be congruent with angle R. Okay. But I imagine a lot of us just saw this and said, oh, we put them equal to each other, and there we go. But this is the whole reason why we can do that. So we get x plus 48 equals 2x. Subtract x on both sides. 48 equals x. And a lot of us ended up choosing B as our answer choice, but B is incorrect because, well, B is our x value, not our y value, or what, not our degree value. We're looking for measure of P. But if I plug this right back in, we get 48 plus 48 equals the measure of angle P. That's 96. So these interests over here are incorrect. Okay. Next one's here. Okay, which additional statement would be sufficient to prove triangle ABC is similar to triangle EDC? Okay, remember we're working with similar, and similar is not the same as congruent. Okay, to be similar, it means to have the same shape but different size. Congruent means to have the same shape and the same size. So by definition, they are both not necessarily opposites of each other, but definitely not the same. Okay. And so I already have a side I'm gonna put a squiggle here because that's how I know I have similar sides. And I also have vertical angles. Okay, so can't forget those vertical angles there. Okay, so make sure that you know that. And so to have sufficient enough information, I need to have another angle or I need to have another side. But the sides have the caveat, they have to be similar, not congruent. So if we look at A, it says AB is congruent to ED. Well, I don't want congruency, so that's automatically out. B, measurement of angle DCE, right? So this vertical angle that we just said is congruent to ABE. Well, I can't, I can't even do that. It doesn't exist. B is wrong. Okay. And C, well, C could possibly be it. If we were to say that these two are parallel, we could probably say that alternate interior angles are congruent. Okay, that could work. And then D, no extra information is needed to prove. No, we need more information. Okay, we don't have enough information. We have to say C is correct here. Okay. Rhombus, HIJK is shown below with diagonals HJ and IK. If HJ equals 24 and IK equals 10, what is HK? We want this here. We know HJ is the diagonal from left, top left to bottom right. And something that we should know about rhombuses is that they are going to, the diagonals are going to bisect each other. So if HJ and IK are diagonals and they bisect each other, that means that we're going to take HJ and IK and split them into two. HJ split into two is 12, so that this value between the middle point um, and the H is going to be 12. Same thing with middle point and J, it's also 12. And then IK will have 5 and 5. Something we should also know about rhombuses is that they are also going to be 90 degrees in the middle. So these here are all 90 degrees, which then means I can actually solve for this. And if I know that HK is my hypotenuse, that's going to be my C value. I take 5 squared plus 12 squared equals C squared. And if you don't know your Pythagorean triples, you can just do this out nicely. Okay. 44 C squared. 25 plus 124 or 144 is 169 equals C squared. C equals the square root of 169, and 169 is a perfect square. That is 13. C is my right answer here. Okay. Just gotta be careful there. Yeah. It's okay not to know your Pythagorean triples. Okay, it's a nice thing to know, just in case for a problem like this one where it makes it a little bit simpler for you, but it's not necessarily necessary. Here, we can do this one of two ways. Okay, let's first read it. The U.S. National Park Service wants to plant a U.S. flag in the midpoint at the longest part of the lake as shown above. If the flag's location is labeled point C, what is the length of BC? Okay, this is a bit of a trick question. For one thing, what's midpoint? Okay, so the first route, route 1, find midpoint, find midpoint, find distance. Okay, so you can find the midpoint and you can find the distance. That's route 1. Perfectly fine. Route 2 is find distance. Okay, find distance, divide by 2. Okay, well, if I have a midpoint, that means that there's a direct middle point of my segment. So if it's 10 feet, then the middle of my segment is at 5 feet. That means both segments are 5 feet. So that is gonna make it out to here too. It's gonna make sense here. So I find that route 2 is gonna be easier, but I think a lot of us need to use route 1. Okay, but I'm gonna use route 2 here. And so I'm gonna take the distance between A and B. I'm gonna use Pythagorean theorem. Connect all this stuff. Connect here. Between A to B, that is 17. And from B to A, vertically is going to be 8. Okay. And so I'm going to set up my equation. I'm going to get 8 squared plus 17 squared equals C squared, or in this case, AB squared. I get 64 for my 8 squared, and for 17 squared, I get 289 equals C squared. And then we just add them up. I get 353 equals C squared. Square root both sides. You can approximate your answer to the nearest 1,000, 18,788. And so this is in miles. It's going to be E as our correct answer here. Okay. If two angles form a linear pair, then they are supplementary. Okay. However, if angle 1 and angle 2 are not supplementary, what other conclusion can be made? Well, if they're not supplementary, that means that they don't equal 180 degrees, which is possible that they equal any other angle measure. And so saying that they have to equal 90 is just not correct. Okay, doesn't make any sense. Angle 1 and angle 2 form a linear pair. No, that doesn't make sense either, because the definition of a linear pair involves being supplementary. And now we're down to B and D. Well, D is, I usually say that if there's no right answer, it's usually because that there for sure is not one. But I would really err on the side of caution. I would say if you think there could be an answer, I would go with the actual answer rather than the non-answer. Okay. And so by definition, if you're not supplementary, you cannot be a linear pair. So B has to be the correct answer here. Next problem. Which statements below are true? In the image below, line K is parallel to line J. It says that 1 measurement of angle 9 plus measurement of angle 16 equals 180 degrees. That one is not going to be correct. Okay, I think there's actually supposed to be an additional piece in this problem. I think it was supposed to be that angle 2 is congruent to angle 7, I think. I think there's supposed to be some additional information there. Okay. Well, even just looking at it, right, we have angle 9 here, and we have angle 16 here. They're alternate exterior angles, which doesn't necessarily mean that they're going to equal 180. It's possible, but no, not really. Probably not, actually. So anything with a 1 is going to be automatically incorrect. Which leaves us to say that 2 automatically is correct because B and D have 2. And now we have to figure out if 3 and 4 are correct. 3, measurement angle 10 plus the measurement angle 3. So this is 10 and this is 3 equals 180 degrees. And this is where it can get a little bit trickier, okay? 10 corresponds to 2. Okay, angle 10 corresponds to angle 2. And angle 2 and angle 3 are supplementary, which means that they add up to 180 degrees. But if 10 equals 2, then that essentially just says that 10 plus 3 equals 180. And I would probably venture to say that this is going to be the correct answer. Okay. But let's just go ahead and confirm 4, 7, and 12 are corresponding angles. 7, 12, they are not corresponding angles, therefore that cannot be correct. Okay. It is much easier to prove something is wrong than it is to prove something right. And so I would rather you try to prove something wrong rather than prove something to be right. Okay. Because when you do prove something wrong, it makes it easier on you to say that, oh, this must be the correct answer because I'm eliminating these other answers. These other answers that don't make any sense. Okay. That's my recommendation. Unit 4. Perform the following composition and transformations on PQR. What are the coordinates of the image? Transformation 1, dilation with the scale factor of 1/2 and a center of the dilation at the origin. So that's the nice one. Transformation 2, reflection over the y-axis. And we're looking for all coordinates. Okay, so Remember, when we have a dilation scale factor of less than 1, that means that we are going to have a reduction. And because we have it at the center of the dilation, we're going to have, k times x and a times y. So it's going to be an easy dilation for us. Reflection over the y-axis, right? Imagine your y-axis. If I have a point right here, then my y-axis is here. I'm going to just flip onto the other side. Okay, so the y value isn't changing itself. The x is turning negative. So negative x comma y. Okay, we'll do the transformation first. And actually, to kind of help us here, I'm going to take only 1 point and then find out of my 4 answer choices here which one is correct. Because if you look at P is a different answer choice every single time. So 4, 4, negative 2, 2, 2, 2, negative 1, and positive 1. Okay, so I'm going to just take P for this example. 4 comma 4 is my P value. And I'm going to multiply by that half. So 1/2 is 4, 1/2 is 4. That, of course, equals 2 comma 2. And then I'm going to put that negative in front of it, negative 2 comma 2, which means that C must be my correct answer. So instead of having to do 3 points of work, I only had to do 1 point. Okay. Think smarter, not harder, guys. Next problem. MN is perpendicular bisector of XZ. Good. Okay. If the measurement of angle MNZ is equal to 16x plus 10 and XYZ is 65 degrees, what is the value of X? So let's just go ahead and label these parts. So XYZ is this angle. MNZ is 16x plus 10 degrees. And what is the value of X? Well, this is where it can get a little tricky, right? It says that MN is the perpendicular bisector to XZ, which means that these two angles must be, 90 degrees. So really, this XYZ angle here is a distractor, okay? Because we don't need XYZ to solve this problem. We know that 16x plus 10 must equal 90 degrees. And so we just solve it out. And so we get 80.
Good morning. Teacher, please excuse this interruption. If you are a test administrator, please make sure that you check the Alpha staff link on the one-stop shop to make sure that you are coming for the right room. I encourage everybody to kind of check their assignment for this. You've had a little confusion with it, so please check your assignment before coming to conference room B or A to pick up your materials. Mr. Alanis, can you come back to conference room B? We have one more sheet for you. Thank you.
Okay, before I was so rudely interrupted by the announcer lady. I solved the last problem, and here's the next problem. Midpoint to midpoint is what we call the mid segment of CDE that joins CE. Okay, so CE is the left side and DE is the right side. So we're gonna have some midpoints here. Okay, I just made it arbitrary. Okay, I didn't actually solve it. But in this problem, you have to solve for your midpoints. So the best way to do it is kind of just to take your rise over run. So if I take my rise over run, I go 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, and I split that in half essentially. Well, 8 divides into 4 pieces. So 1, 2, 3, 4. So I'm going 4 up, and I'm going to go 1 over. So this is my midpoint, which I wasn't too far off. Same thing with ED. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. I'm going to go 4 to the right as part of my midpoint, but then I would split it into half. So I'm going to go 2, 2, and then down 3 because I had 6. 1, 2, 3 here. Again, wasn't very far off, actually. Pretty good. And so that these two equations, we have a 3, 6 And then we also have a 6, 7. And obviously you only need one. Well, actually, no, you don't need one of those. No, you do. You do. Okay. If you only found one of these midpoints, you could have solved this because remember, a mid-segment is always going to be parallel with the segments that it is opposite to. So because we have the mid-segment of CE and DE, that means that this must be parallel with this line right here. So we find the rise over run. 1, 2, 1, 2, 3, 4, 5, 6. So we have a 2/6 slope, which means that our slope's got to be 1/3, and it is going upwards, so it's positive. And so I have enough information to put it into my point slope formula now. So y minus 6 equals 1/3 times x minus 3. And so I look around, do I have this answer choice? Close for F, but not quite. Oopsies. Close for F, but not quite. So that's enough. That's a wrong answer here. And it looks like none of the other ones work. So let's use the other midpoint. Y minus 7 equals 1/3 x minus 6. And do I get that as an answer choice anywhere? That is H. And there we go. I have about 6 more minutes. I'm gonna try to get through as many more of these as I can. I think. How many more questions I have? 1, 2, 3, 4, 5, 6, 7. I have 7 more questions or 6. Ugh, okay. I'm gonna try to go this fast. Okay. What are the missing reasons in the proof? Parallelogram ABCD with diagonal BD. Prove that ABD and CBD are congruent. Okay, so it says ADB is congruent to CBD, ADB, and CBD. Okay, so we know that this one has got to be true. So these two angles have got to be true because this is a parallelogram. Parallelograms are congruent and they're parallel. And we also know that these angles here are going to be congruent. And we know that this side here is congruent. Okay, there's a lot of information that we know. Actually, there's a ton of information that we know. I'm looking at this like this. I don't know. This proof would have been a lot. Been done a lot sooner than I thought it would have been. Anyway, but we know that this is true because of alternate interior. And this is where you again have to prove things wrong. To then get to your answer. So A and B are automatically out. They're done. Okay. Automatically done. Out of here. Okay. And so we look at 2. So we're already done with 4 and 2 because 4 has the exact same reason as 1. DB and DB, that's reflexive. And so since D doesn't have reflexive, it's going to be C. Triangle ABC is equilateral. BF is the angle bisector of ABC. Prove that triangle ABX is congruent with CBX. And there is a way to do this, but I don't have enough time, so I'm going to skip it and to do more problems. So he examines the following quadrilaterals. He makes the following conjecture. If a quadrilateral has at least one pair of parallel sides and at least one pair of congruent sides, then it has congruent diagonals. Which quadrilateral is a counterexample to his conjecture? So remember, we want to prove the first part. Prove first part. And disprove second. Okay. So if a quadrilateral has at least one pair of parallel sides and at least one pair of congruent sides, so looking at all these quadrilaterals, okay, 1 definitely has at least one pair of parallel sides. That's good. And one pair of congruent sides. That's good. So we'll keep it. 2 has only one pair of parallel sides. They're not congruent, so we can't use 2. Same thing with 3. We have at least one pair of parallel sides, one pair of congruent sides, so we'll keep it. 4 is a trapezoid. It only has one pair of parallel sides, and it doesn't necessarily have congruent sides. Okay. So then we want to disprove the second part. So then it has congruent diagonals. Well, in 1, this one shows that they have congruent diagonals. That would be correct for the conjecture, but we want a counterexample. So 3 has to be the correct answer. Okay, we know 3 to be the correct answer because it does not have the congruent diagonals. Does not have congruent diagonals. So disproved. Second part. And this is what we call the counterexample. Very good. Then we have 3 more problems. Oh my gosh, 4 more problems. Oof. Yeah. Oh, 2 minutes. Consider PQR and XYZ. Let PQ equal 3 times x minus 4, XY 5x plus minus 16, PR 7.5, and XZ equals 15. What is PQ? Oh boy. 3x minus 12. I'm going to simplify some things. XY is 5x minus 16. And XZ is 15. What is PQ? So we're dealing with some similar triangles. But oh, say there it is. Okay. The PER is 7.5. Here you get to choose what you want as your old and what you want as your new. So this is old, this is new. How did we get from 7.5 to 15? And that's of course going to be multiplying 2. So because we have a scale factor of k equals 2, we're going to take 2 times 3x plus 12 minus 12 equal 5x minus 16. We get 6x minus 24. Make sure you distribute, equals 5x minus 16. We'll put all the x's on the left-hand side, put all the y's on the right-hand side, or put all the non-x's on the right-hand side. We're going to get x equals 24 plus 16, or sorry, 24 minus 16, because we get a positive 24 plus 16 plus negative 16. We're going to get 8. X equals 8. Therefore, we plug it right back in. 12. So 24 minus 12. We get 12 as an answer choice. D is our correct answer. Okay. Wrapping it up. The altitude of a triangle has a vertex of -5, -7, intersects line R at the point 3,5. If line R contains the opposite side of point A, what is the equation of line R? So here we got to find our slope, and we're going to take our slope. It's our y2 minus y1 over x2 minus x1. And remember, y2, x2 have to be the rightmost point, in which case the rightmost point is this one. So x2, y2, x1, y1. So 5 minus a -7 and 3 minus a -5. We're going to change those all to positive. We're going to get 8 here. We get 4. Nope, not 4. 3, 2 as my slope. And I have a vertex. So 3 over 2 as our slope times x minus 5, right? So double negative equals y minus 7. And then because it's all in slope intercept form, we have to change it to slope intercept form. So y equals 3 over 2x plus, well, 3 times 5 is 15 over 2 plus 7. So we get y equals 3/2 x plus, well, 7 is equal to 14 over 2 and 29 over 2. Yeah, it does not look like that is one of our answer choices. I did this quickly. Hold on. The altitude of the if I use the other point. So y minus 5 equals 3 over 2, x minus 3, y equals 3/2 x minus 9 over 2, which is the same thing, and then plus 20 over 2. No, not 2. Like so 10 Oh, no, I had to subtract. I had to subtract 2. So 15 minus 14 is 1/2. There we go. Okay, so you gotta make sure you're not working too fast. Go. Okay. Triangle ABC is graphed on the coordinate grid below. D is the midpoint of CA and E is the midpoint of CB. Which statement cannot be proven true? I don't know this off the top of my head. CD is okay. So then that means that this is the mid segment. DE is going to be parallel to AB. So if that's going to be its choice, that's correct or incorrect. AD and DC are going to be congruent. That's not necessarily always true. CA and CB are congruent. That again, it's also not necessarily true. 2 times DE is equal to AB. That one is for sure true. So it really boils down to A and C. Well, AD and D. No, AD and DC is true because D is the midpoint, so C must be correct here. Okay, last question. In parallelogram FGHI, diagonals IH and FH are drawn and intersect at point M. Which of the following statements must be true? I don't actually know this off the top of my head. I'll put it in the description of the video, but I don't have enough time. I need to let you guys in. Okay, so again, make sure that you're studying. I'm going to stop recording and I will talk to you all later.